All right, so here we are with lesson 1.2, angles in a unit circle. You can read these definitions. We're going to talk about a couple of them here with these diagrams. So first of all, let's talk about this diagram here of an angle in standard position. That means that the initial side, okay, is on the positive x-axis. And the terminal side, remember terminal means end, okay, would be the angle that we're actually looking for. So this will be defined as angle theta. Okay, a couple other things here about a unit circle, right? That's one of these things, definitions here, is a unit circle has a radius of 1. So it doesn't matter where you are on the unit circle, that will be your radius, and it equals 1. All right, so if that's true, that means we can define each of these points here, all right, using the idea of a unit circle, or and a coordinate plane. Okay. And that'll come back to that later. All right, so let's talk about some of these angles in standard position. So counterclockwise rotation, all right, are positive angles. So anytime we have a rotation that starts at the x-axis and goes up, all right, that's going to be a positive angle. All right, so we know that if halfway around, excuse me, the circle is 180 degrees, or we know at least that a straight line is 180 degrees, then we can determine what angle theta is here based on the information given. So we would just do 180 minus 45, and we would find out that angle theta here is 135 degrees, and it's positive. All right, whereas over here, because we're starting at the positive x-axis and going down, all right, our angle is going to be negative. Okay, so let's see here. We're just going to use a couple different references. First, that this is 90, okay, and then we have an extra 30. So 90 plus 30 in this particular case, all right, is 120, but for the angle itself, it's actually negative 120 degrees, all right, because again, it goes backwards. All right, so 1 full rotation is 360 degrees. That means a quarter rotation is 90. That means a half rotation is 180. And that means 3/4 rotation is 270. So that unit circle we started with, this would be 90 degrees. This will be 180 degrees. This will be 270 degrees. And this will be 360 degrees, or 0 degrees before you start. Okay, so let's sketch each of these angles. So 85 degrees. Again, you're not going to get this to be accurate. You could use a protractor to do this. We're not going to. All right, so 85 degrees I know is really close to 90. So basically, I'm just grading on your ability to put that angle, relatively close to 90. So I would say that is 85 degrees. Okay, negative 320. So let's think about this. Negative 90, right? Negative 180, negative 270. Okay, and then that 320, that's 40 degrees away from 360. All right, so that's going to be about halfway. So my whole angle here would start at the positive x-axis, go backwards, and that's negative 320 degrees. Okay, 210. So 210, we're going to go 180. All right, and then we're going to go a little bit past that. So 30 degrees past that would give you 210. So that would be 30. So my actual angle here starts at the positive x-axis and goes all the way to that terminal side, and that is 210. And then negative 135, again, negative 90. Okay, negative 135. It's going to be halfway between negative 90 and negative 180. So that means this reference is 45. So the actual angle, if I draw it from the positive x-axis, would start here and go to that spot, negative 135 degrees. And the more familiar we make ourselves with each of those sort of quadrants, if you will, it's now one word, the better we'll get at this. So coterminal angles. So two angles in standard position are coterminal if they have the same terminal side. So we can get to each of these angles two different ways. So in other words, 135, all right, so the angle for 135 would be right here, okay? That's the positive angle to get to 135, all right? Negative 225 would be the negative angle to get to the same place. So negative 90, negative 180, all right, 45 degrees more is negative 225. They're considered coterminal because they have the same terminal side. They both end at the same place, okay? And a way to check that would be just to take those two angles, all right, 135 and negative 225, and if you add their absolute values together, it should equal 360. Okay, find another coterminal angle with 198. So if you're looking for coterminal angles, the easiest way, okay, to that is to determine what angle would make that 360, okay? All right, so that's one way to do this, okay? But then remembering that that can't be positive, right? It has to be negative because if you go the opposite way around the circle. But there's an easier way. So the easier way would be to take the angle you have and add 360 to it, or subtract 360 from it. Okay, and that will give you multiple coterminal, and you could keep doing that process. Every time you add 360, it's going to be a coterminal angle. All right, so we end up getting 558. All right. Could be an answer, or negative 162 could be an answer. And I can repeat that as long as I need, as many times as I need to. So are the angles with 40 and 680 coterminal? So what we want to do here is we want to try to figure out 680, whoops, minus 360, okay? So I take 680 and subtract 360 from it. I'll get looks like 320. So that doesn't equal 40. So I subtract 360 again, and I get negative 40. Doesn't equal 40. So no. Angles in the unit circle. So this is a little bit different. We're going to refresh our geometry here. Now, remember, in geometry, you used 30, 60, 90, 45, 45, 90 were special right triangles. And in geometry, you said that this side was, excuse me, when the hypotenuse, you tried to come up with a pattern. So when the hypotenuse was 2, this side was root 3, and this side was 1. Okay? However, on the unit circle, the radius is always 1, which means we simply have to take each of these and divide by the hypotenuse. Okay? So for the unit circle, the hypotenuse is 1 because the radius is 1. The side across from the 30 is half the hypotenuse. And the side across the from the 60 is the square root of 3 over 2 times the hypotenuse. All right? Same thing over here. In geometry, you learned this as isosceles. So you said this was 1, this was 1, which Pythagorean theorem tells us that equals root 2. However, on the unit circle, we don't want that. So we have to divide all them by root 2. All right. So if we divide this by root 2, divide this by root 2, divide this by root 2, all right, we get 1. We get root 2 over 2 if you rationalize it, and root 2 over 2. Then all we do is we take each of those special right triangles and we lay them over this unit circle to determine the coordinates all right, that the terminal side makes on the unit circle. So this right here is a 30, 60, 90. So that's 30. Okay. Which means this is the long side. So the x value is the long side, root 3 over 2. All right. The y side is the short side across from 30, so 1/2. Okay. Over here, again, this is a 60 now, okay? So the short side is the x side, but I gotta remember I'm in the second quadrant, so x is gonna be negative, so negative 1/2. All right, but y is positive, so root 3 over 2. Okay, and then the final one down here is in the third quadrant, which means I'm gonna have negative, negative. It's also a 45 is the reference, okay? So I'm gonna have negative root 2 over 2, negative root 2 over 2. We'll expand on this idea of the unit circle, all right, in the days to come. All right, so a little review here. Again, we're all over the place with some geometry here. Trig ratios, so COTOA, right? You should learn that in geometry. It's how you remember sine, cosine, tangent, angle side ratios. All right, so sine is opposite, all right, over hypotenuse. Cosine is adjacent, which means next to, over hypotenuse. And tangent is opposite over adjacent. We'll see what that looks like in action here. Okay. Draw the angle, find the cosine and sine of each angle. So 135. Again, what I'm trying to envision here is where does that angle occur? Okay, that angle actually occurs in the second quadrant. Okay, it's 135 from the positive x-axis. So what I want to do there is drop down a vertical, think about the horizontal. Okay, determine this is 45. I do that by knowing these are a linear pair to make 180. And then I use my special right triangle for 45. So I know this is negative root 2 over 2. And this is positive root 2 over 2. Okay. Now, if this is my angle, okay, the opposite side, okay, is sine. So sine opposite of hypotenuse. So the sine of theta would equal root 2 over 2. The cosine of theta would be the adjacent side. So cosine of theta equals negative root 2 over 2. All right. So let's take a look at 150. Again, still in the second quadrant. Not quite 180. Okay. So if this is 150, that means my reference angle here is 30. Okay. So you can go about this two different ways, right? We could use this idea of the unit circle, or we could just refer to our original special right triangles from Geo. It's up to you. So if this is 2, that makes that 1, and that makes that root 3. If I'm finding the sine of theta, that's opposite over hypotenuse. So opposite of theta is going to be 1, hypotenuse is going to be 2, so I get 1/2. Okay, cosine of theta is going to be adjacent over hypotenuse. Again, if I go back down to my triangle, adjacent is next to, and then hypotenuse. All right, so I end up getting root 3 over 2. Now that one's negative, because I got to remember, this is sort of like a geometry and an algebra combination here. This x value should be negative. 30, that's an easy one. It's the first quadrant one. We don't have to worry about signs. Okay, this is the 30. Okay, drop that down. There's your right angle. All right, if I'm using the idea of the unit circle, that means that's 1. That means this is root 3 over 2. That means this is 1/2. Sine's always going to be the y side, the opposite side of the angle. So the sine of theta is going to be 1/2, or the sine of 30 is going to be 1/2. And then the cosine, all right, is going to be root 3 over 2. Okay. And then hopefully you're noticing a little bit of a pattern here. The 120, all right, again, that's a second quadrant one right there. Okay, it ends up being the 60 for the reference angle. Okay, so this is 60. All that does is change, okay, what's my short side? All right, so that's going to be negative 1/2, and this is going to be root 3 over 2. So again, the sine is always opposite. Opposite is sine. So the sine of 120 is going to be root 3 over 2. And the cosine of 120 is going to be negative 1/2. All right, so find the exact values for cosine of negative 120 and sine of negative 120. Sketch the angle. All right. So negative 120 would start at the positive x-axis. Okay, it would go backwards. Okay, to there. The reference angle there is 60. So that means that the sine side is opposite. All right, and the cosine is adjacent. So this is cosine, this is sine. Okay, and again, I can use the unit circle reference, or I could use my special right triangle reference from Geo. All right, so that would be 2, that would be negative root 3, this would be negative 1. So if I use geometry here, I would find out that the cosine, all right, of negative 120 gives me negative 1/2, right, because that's adjacent over hypotenuse. And then the sine of negative 120 is going to be negative root 3 over 2, right? And that's opposite over hypotenuse. Use a calculator to find each of these, and we want to find these as decimal values. Typically, we won't do a lot of this, but you still need to know how to use a calculator. Make sure your calculator mode is in degrees. You really have to verify that. So if you're using the one on the iPad, all right, that probably comes programmed in there. Okay, you got to go to mode, and you got to make sure the toggle down here is set to degrees. All right, and then you should be able to just as simple as type these in. All right, so cosine of negative 120 degrees, hit enter, it'll give you the answer, negative 0.5. All right, so these should be easy for you to do. All right, so this one here is negative 0.5, whoops. Okay, this one here is negative 0.87. This one here is negative 0.71. And this one here is positive 0.71. All right, now again, you'll memorize these as special, okay, and you'll memorize them as exact answers, but for now, we were looking for decimals. So that's 1.2.